Hello, and welcome back to part 2 of the breakthrough tutorial for drag and drop. So last time we got the core of the game working, all of the movement and collisions. But now we are going to be implementing a lot of the effects on things like the score and the lives. We'll have the bricks actually destroying themselves when they get hit. We'll set up our winning and losing conditions, and we'll also polish it off with some sound effects. So to get started, let's set up the score and the lives. Now, I'm going to be using a new object for this, and I'm going to call this obj control. And this is going to be a kind of special object that is invisible to the player, so the player won't ever interact with it, but it's going to be taking care of things behind the scenes. So it's going to be managing some of the logic for the win and lose condition, and it's going to be creating those important variables. And we're going to be creating a score, a high score, and the player lives. Now, if you think about it, we want the high score to persist throughout the game. So even if we restart the level, I don't want the high score to be changing. So we can't use the create event for them, because when we restart the level, that will destroy and then recreate the instances including obj control, which means the high score will be getting a reset back to 0. So I only want to initialize it once at the very start of the game, and luckily there is an event for that. So game start, which is down in other. Now, there are actually built-in functionality for score and lives, but there isn't really one for high score. So what I'm actually going to do is declare all of these as global variables, and that way we get to learn about what these do. So a global variable is kind of special. It's different than the normal variables, for example, that we created in obj-bat, like speed. And also variables like x and y, those are also instance variables. They are unique to that instance. And their scope, which is kind of how we can reference that variable, is also limited to this instance. And what that means is if I try and reference SPD in obj-ball, it's not going to work. It's going to try and reference its own version of that variable. So just like when we reference x and y, we're referencing our own x and y, not someone else's, unless we explicitly state that with something like the dot operator. And also, instance variables are deleted when the instance itself gets deleted. So SPD, x and y, everything that belongs to obj-bat, that is going to be deleted from memory when that object gets deleted. Which is not the case for a global variable. Global variables don't belong to any instance. Their scope is global. So if obj control gets destroyed, it doesn't matter. That variable is going to persist in memory throughout our entire game. So we do kind of have to be careful with our global variables. We don't want everything to be a global variable because that's going to be taking up all of our memory. That said, you can create probably thousands of variables before it actually has an effect on performance. But it's good practice anyway to only make things global when it makes sense for them to be global. So when lots of instances might be interested in one particular variable, which is definitely the case for the lives and the score. There's only going to be one score, one high score, and one set of player lives. And we do want to reference them in other instances, and we want them to persist for the whole game. If you just click plus here, then we can actually declare multiple variables at once. So let's go player score. And there it is in the autocomplete, so that's how we might reference it later. We want high score. And player lives. But we'll start that one off at 3. Alright, so those are all our global variables. Now we should actually draw them to the screen. So let's add a new event, and we're going to be using the draw event. So draw events are special. They're the only events that we can actually draw elements to the screen in. You can't draw things in the step event. Even if you drag the action blocks in, they're not going to work. So we're going to be just using the normal draw event. These other events are if you want to be specific about when you want the drawing to be. So you might want to draw something on top of everything else. Then you might use draw end. But we're just going to be using the normal draw event, which is when most things will be drawing themselves. So actually putting this in will override the default event where the object will just be drawing itself. But that's fine. We don't need obj control to be showing up. Alright, so now let's draw our scores to the screen. So we're going to be drawing text. So let's type in text, and we want to be using this one. So draw value. So the caption that we want is going to be score. And then the actual value, well, here we want to be referencing our global variable. And instead of just writing the name player score, because it's global, we have to put global dot beforehand. Global dot player score. All right, now the X and Y position that I want to draw this, I might draw this up the top, but not quite at 0, 0. I might draw it a little bit down. So I'm going to say 8, 8. And we don't want this relative to where obj control is in the room. We want it at those absolute coordinates. Now, before we run the game, we have to, of course, put obj control in the room. So let's drag it in now. And like I just said, it doesn't really matter where we put it because it's going to be drawing the elements at that specific location that we told it to. But the convention for these sorts of controller objects is to place them at 0, 0. So that's what we'll do. And let's run the game. So there we go, it's drawing it up the top. But how about instead of using this default font, let's create our own one and use it to draw the score with. So I'll just quit out of that and we'll come over to fonts, create a new one. I'll call this FNT_game. And you can pick whatever one you want. I might go with impact. It's nice and big. And I'll increase the size up to 20. Now all we have to do is set that font. And we have to make sure that we're setting it before we draw it. So we could put it up here, but we actually only need to set the font once because I'm going to be using this font throughout the entire game. I'm never going to change this font. So if I put it right here in the draw event, then that's actually going to keep setting the font every frame of the game because the draw event runs every frame of the game, just like the step event, because elements need to be drawn constantly to keep appearing on the screen. But we only need to set the font once, so we could put it in the create event or something like the game start. So let's do that just in here. So I'm going to just type font, and we want set the font. So we'll set that to FNT game. Okay, so now if we rerun that, it should come up in our nice big impact font. There we go. Okay. Now, as well as the score, let's also draw the high score. And global.highscore. And as for its position, I'll put it at 8 for the Y as well. But for the X, I want it over the other side of the screen. So I'm going to go room width and then -8. But you'll see, if we run that, it's going to be kind of aligned incorrectly. So by default, text is aligned to the top left, right? So that's kind of like its anchor point, which is why it's anchored right here and then goes up to the right. So for this one, we actually want to align it to the right so that it draws kind of that way. So let's set the alignment right here to the right. But if you run that right now, you're going to see that this one will also be aligned to the right because as soon as we set that, that will impact everything that draws afterwards. So once that frame is done and it comes back and starts the next one, it's going to be drawing the score with the right alignment. So we want to change it back to the default. And you should do it actually right at the end of what you're doing because in other events, you might also be drawing text and you're going to expect it to be at normal, so make sure if you change something, change it back afterwards. Alright, let's test that. There we go. Now for the lives, instead of drawing numbers, I'm actually going to be drawing sprites right here, kind of like the hearts that you might see in a lot of RPGs like Zelda. So I'm going to create a new sprite for this. You could create a heart, just as I said, but I might just create a smaller version of the bat. I'm just going to duplicate that. And I'll just call it SPR lives. And I'll come into this. And I'm just going to draw a smaller one. And I'm going to keep the padding around the side because when I stack the sprites, I want there to be a little bit of room between them. And I'm actually just going to cut this entire thing. And the cool thing about that is it creates a kind of brush that you can then use to draw with. Like that. It looks a little bit weird with such a big sprite. But you can create your own kind of custom brushes that way. And then I'm going to paste it on, but at a lower alpha, just so that the lives appear a little bit transparent. All right, so that is my life. And let's come back to obj control. And now we are going to draw a stacked sprite. So this one right here, the little hearts. So we'll drag that in, and now we are going to set what sprite we want to draw, so that's SPR lives, the stack order, so horizontal, the number of lives now. So I don't want to just put 3, even though that's what we start off with. I want it to draw as many lives as we have lives. So whatever the global.player lives is equal to. So that we can put that right in. And now for the X and Y. For the Y, I'm going to have it be basically down the bottom of the screen, a little bit below where the bat is. So let's go room height. And then -32, so just a little bit up. And now for the X, I want it to be in the middle. So room width over 2. And let's just test that. That's not going to be quite right, but I want to show you exactly why that is. So there we go, the lives are drawing right here, but if we want this to be perfectly centered, then we might have to do a little bit of maths. So let's go through this in our head. For example, if we have 3 lives like we do right now, we don't want to just start at exactly half the room width. We also want to subtract half the amount of space that this is taking up already. So to calculate that, we need to get half the number of lives times the distance between them, and that's going to be just the width of the sprite. And remember that was 64. So, and this might end up being a little big, but let's go with it. So room width, and then we want to subtract half the amount of lives. So we'll go global.player lives, and then we want to multiply that by the width of the sprite. So that was 64, but then we want to halve that. And let's just make this a little bit wider so that we can see it. So there we go. But instead of putting global.player lives times 64 over 2, we can kind of cancel out that 64 over 2 and just put times 32, so half of 64. Just like that. And if we run that, that's almost right, but you'll see actually that's 1 too many over. That first sprite is in the wrong spot. We don't actually want to include the width of that one, so we're going to go player lives -1, and then we'll have it right. So we'll test that one more time. There we go. So now we have all of our important variables set up. When we hit the brick now, we should actually make it destroy itself and also add to the score. So let's go off to obj ball. When it collides with the brick, we also want to be destroying that brick. So let's type in destroy, and there we go, destroy instance. But as it is, that action block is actually going to destroy whatever instance runs it. So that would be destroying the ball, which is not what we want. We want to be destroying the brick. So if we go and click this little drop down right here, we can actually apply this to a different instance. So let's click that. And again, we can use that special keyword other to reference the other object in this collision. So the brick that we just collided with is going to destroy itself. So now we can reset that global variable, player score, and let's increase it by whatever you want. I might just do 15, but we also want it to be relative to what it currently is. I don't want to just set it to 15, I want to add 15 to it. Perfect. Now, another thing that we can add here to just make the game a little bit more dynamic is to increase the speed of the ball when it hits a brick. So currently it's moving a little bit slowly, so if we add to the speed of the ball every time this happens, then we're going to get a more kind of exciting game. So you can increase it by however much you want. I might just do a small number, but that might not be enough for you. Remember to tick relative so it actually adds to whatever the current value is. And you might also want to set a maximum speed so it can't go past a certain speed. So for example, what we could do first is check if speed is less than some maximum value. So for example, 12, only then will we increase the speed. But you might not want that. You might want to just let it increase as far as it can go. But now if we run the game, when we hit a brick, our score should go up and the brick should get destroyed. Perfect. Now, another thing that we want to do is if the ball hits below the screen, then we want to take away one of the player's lives and also restart the level. So to do that, then we need to come over to the intersect boundary code. So in here. So we set up all of the boundaries except for the bottom one. And we were testing to see if the bounding boxes of the particular sides of the ball were over the boundary to actually see what boundary we were hitting. So we want to check if the bottom of the ball's bounding box is greater than the room height. So let's check. bbox bottom is greater than room height. Then, if it is, we want to subtract a life. So again, let's set a global variable, player lives, and then we want to set this to subtract 1 relative to what it currently is. And we also want the ball now to go back to the player. So what we can do is destroy this ball that's currently gone off the screen with that instance destroy function that's probably up here in your recently used. So we'll destroy that ball and then we can actually just recreate another ball at the starting position so that its variables for go and all of its logic are going to be reset as well, ready for us to kickstart the ball again. So we've destroyed it, now let's recreate another one. So we're going to create an instance of obj ball, and the position that we want to start it off at is where we started. And there is a special variable called xStart that holds the position that we started at. And we can do the same for yStart. And we'll create it in the instances layer. That should be the default name of the layer if you haven't changed it, that's in your room. This one right here. And you can see that we've put it in quotation marks like that. That's because this is actually called a string. So it's different than a variable or a real. A string is always in this kind of inverted commas. It's how we write text. Target would be if we want to save the ID of this instance, which we don't, so we can just leave that. And while we're at it, we could also make the player's bat go back to the middle of the screen. So how about we do that? Let's change the variable. So assign a variable. And now, just as before, I don't want to actually be applying this to the ball's x, right? That's an instance variable. We want to apply this to obj bat. We can't use other, we're not in a collision event or anything, we have to reference the object. And luckily there's only one obj bat ever, so we can safely reference this one. So we want to set its x back to its x start. So it's going to be referencing its own variables here. So let's run that. And if we let the ball go below our bat, there we go. So it's taken away one of our lives right here, and it has also restarted the level. And if we had the bat away, it should also move the bat exactly like that. Perfect. Now, in the case that the player has no lives left, then I actually want to be restarting the entire game and checking if whatever our current score is, checking if that is higher than whatever is in the high score variable. And if it is higher, then we'll set it to a new high score. So let's do that. So we need to check here to see if the player has no more lives left. So let's check if, and I'm actually going to put this after here. So after we have decreased the lives, what we're going to do is check if player lives, but now because we're not using a global variable action block, we actually have to use global dot again. So global dot player lives, that tells it that it's a special global variable. So if that is, we probably could just use equal because it should never be going below 0. But just in case it does, just in case there is some kind of bug in the program that's affecting something when it wasn't supposed to, something that we didn't take into account, it can be safer to have these checks encompass a larger range of variables. So less than or equal to 0. That is when we should restart the game. So if that is the case, then we will do our restart code, but actually, otherwise, I want to be doing this stuff. So before we move on, I might put all of this into an else. Put in an else. And this means if this isn't true, then do the else stuff. So if we still have lives, then we want to be recreating the ball and letting the player have another go. So we'll put that in the else. Make sure we move both of these into here. All right, and now otherwise, if we have to restart the game now, then we want to do that check to see if the player's score, so global.player's score, we want to see if that is larger than the high score. And if it is, then we want to be setting a new high score. So we could actually use either the setGlobal or just the normal variable here. So we want to set global.highscore to global.playerscore. Alright, so that will set the score, but now regardless of the score, we also want to be restarting the whole game. Now, as it currently is, if we run the game and get rid of all of our lives, then we're actually going to be putting the game in an unplayable state. And that's because we got rid of the ball and we didn't tell the ball to be recreated again. So in that case, I'm actually going to kind of put the game in a game over state where we wait for the player's input, so the player could just press a button, and when we do that, then we'll restart the game. So to do that, we have to, at this point, enter a different kind of state. And the way I'll do that is let obj control know that it's now game over. So let's come to obj control, and in its create event, I'm going to make a new variable called gameOver, and I'll set that to false for now. And then back in ball in here, what we'll do is set that variable to be true once this happens. So we don't want to put it in here in this if check for setting the high score. We want to be setting this game over state regardless. So again, of course, we have to make sure that we're changing the controls instance variable. So game over, and we'll be setting that to true. So now, in this case, we can come back to obj control, and now in the step event, we can wait for the player's input. We'll only be waiting for that special game over reset input if game over is true. In that case, we are going to get some input. So we're going to get some keyboard input, a key press. And this is kind of like those key events right here, except we can actually do it from within a step event. So I just want to show you that we can do that. And I might say any key. So if the player presses any key at all, we're going to reset the game. So in the event that it's game over and we press any key, then what we're going to do is restart the room. So just the level. So that means that the high score is not going to be overwritten. But we do want to restart the lives and score back to 0 because the players died and we want to give them their lives back. So let's reset those global variables. So player score back to 0. And also player lives back to 3. Just like that. Alright. Now there is another time where we want to be restarting the room, and we can also do that from within obj control. And that's going to be when there are no more bricks left. So that will be the kind of win condition for the game. And in that case, we're just going to restart the room, keep all of the variables intact, and just let the player keep going until they die. So what we can do is have our obj control checking for the number of bricks. So let's just type in number. And right here, we can get the instance count of a particular object. So let's get the instance count of obj brick, and we'll save that in a variable called num of bricks. And we can make that a temporary variable because we don't actually need to keep that variable after this frame. It doesn't really matter if we do though, because it'll just keep getting overwritten. And now we need to check if num of bricks, this variable that we just created, so if the instance count of the bricks is 0 or less than 0 for some reason, then what we'll do is restart the room. Just like that. And we don't want to be resetting any variables, like I said, we'll just keep everything as it is and let the player keep going. Alright. So if we give that a test, hopefully all of our logic will be working. You might want to decrease the number of bricks that are in the room so that you can test everything a little bit faster. but we should have everything up and running. There we go. Now at this point, I just want to address something. You may or may not have been noticing some strange behavior with the ball and its collisions. So it's actually possible for the ball to get stuck along the walls of the room because of how we've coded it so far. It's quite a rare bug, but it is actually possible for that ball to go so far over the boundary that when we flip that horizontal speed like we were doing when it hits a wall, that it doesn't have enough speed to get back out of the boundary. So it keeps just flipping backwards and forwards, never able to get outside the boundary again. Luckily, this is actually quite easy to solve. So what we want to do is move the ball back to the position it was at previously. Because there is actually a variable that stores the X position on the previous frame, and that is called X previous. So that's all we would have to do. And let's also do the same for its Y coordinate. And I'm just going to copy that and paste it here because we want to do the same thing in this case. And also here. Except it's pasted it down here, so I'm just going to drag that back up to here. Alright, so now if it hits the left, top, or right, it's going to come back to its previous position and then reverse the speed. So sometimes bugs like this don't appear when you initially test them and then you find them later on. And that's why it's really important to rigorously test the game and consider all the possibilities of your logic. And sometimes putting in checks like this will prevent it from being stuck, but it really depends on how you've coded it. Alright, at this point we have a nice game up and running. And now I want to add in some more content. Power-ups. So basically when I hit a brick, I want there to be a chance that a power-up will appear. So for example, a power-up to increase the size of the bat. So first off, I'm going to create the sprite for that. So I'll call this SPR powers. And I'll change the size to be 32 by 16, about the same size of a brick. And I'll leave the anchor point there, it doesn't really matter. And for this first one, I'm just going to draw an arrow that kind of looks like it's getting bigger. And I'll just color it in yellow. And now I'm going to actually add another frame for another power-up. So I'm not actually going to have two different objects for the two different power-ups. We're going to have just one power-up object, and then depending on what frame is showing, and we can add a new frame by just pressing this plus button right here, depending on that, that's going to be what determines the effect it has on the player. So if the player hits this one, it'll grow, and if the player hits this one, now I'm just going to draw arrows pointing down, then I'm actually going to slow down the ball. Because remember, we were speeding up a ball every time we hit a brick. Alright, so that is our power-ups. Let's create the object for them. obj powers. And we'll assign the sprite. And now, just like the bricks kind of choose the color as soon as they're created, I'm going to have the power-up choose what frame it is. And the way that we're going to do that is set an instance variable. And this one is going to be what's called the image index. So this, and we can actually right click on this and then show help, and that should bring up the documentation for you. So this explains all of the instance variables that you can toggle. And these ones are actually quite important for all instances, so I definitely suggest having a read of this little section. But as you can see, the image index is the kind of frame that the sprite is currently set to. And with sprites that have multiple frames like this one, it is actually going to be animated. And we'll see if this is actually appearing in the game, it's going to animate like this, so we actually don't want it animating. So another thing we have to do is set the animation speed to 0, and then it won't animate. But right here, I want it to choose either frame 0 or frame 1, because like a lot of things in programming, frames actually start at 0. So that would be the first frame, the getting larger one. So we want to use choose again. And we'll have it choose either 0 or 1. We'll save that in frame. Again, that can be a temporary variable. We don't need to remember that one. And we'll set that, instead of just to a value, to our choice. All right. So now, as soon as this gets created, another thing I want it to do is to descend down the screen. So I'm going to set its direction, just like we did with the ball, set direction fixed, and we just want it to go down. And remember that setting the direction doesn't actually do anything, that kind of just makes it turn around and face downwards is what you can kind of think of it as. But without actually setting it to move, so setting the speed, it's not going to do anything. So we'll set the speed, and maybe I'll just set that to 5 in the direction that it's headed. So it should be going down now. And now we have to think, imagine that it's been created. 2 things can happen at this point. So it's going to come down, and then either it's going to collide with the player, or it's going to miss the player and just continue off the screen. And now, this is important. If an object goes outside the room, it does not get destroyed. It's going to persist there and actually keep moving. It's going to be taking up memory and processing, and it really doesn't need to be. So in the event that it goes outside the room, which we can find in other, outside room, then we can just tell it to destroy itself. So this one right here, destroy itself. Otherwise, it's going to be colliding with the player. So let's set up a collision with the bat. I also want it to destroy itself when it collides with the player. And then I also want it to, depending on what frame it is, so let's check, if a variable, and remember that one was called image index. So if that is equal to 0, let's say, so that would be the growing power up, then I want to be increasing the size of the bat. And the way we can do this is, again, changing an instance variable, the horizontal scale of the object. But hopefully you're getting used to this by now. We don't want to set obj powers horizontal scale. We want to be setting the bats. So again, we could put bat, or because we're in a collision event, we can put other. So the normal amount for scaling is just going to be 1. That's the normal scale of an object. To make it a bit bigger, let's scale it to be 1.5. All right, so that's going to increase the size of the bat. But actually, I don't want this power up to last forever. Let's say I only want it to last for like 10 seconds. So what we also have to do is set off a kind of timer that's going to return this back to 1. And to do this, I'm going to introduce a new event. So if we head over to the bat, add event, we're going to add an alarm. And you can see here that you can put 12 different alarms starting at 0. Let's just use that first one. And basically we can set this alarm to go off from within obj powers, and this can turn that, so the horizontal scale, back to 1. Just like that. So we have to set that to go off in obj powers, so alarm. Set the alarm countdown. Again, we have to make sure that we're applying this to other. Alarm number 0, that's fine. And now the countdown. All right. So this says 30, and that actually means 30 steps. And we know that there are 60 steps in 1 second. So that's actually only going to be half a second. If we want 10 seconds, then what we can do is go 10 times, well, we could put 60, or we could put something called room speed, and that's going to be whatever you've set to be the frames per second in your game. That should be 60 if you haven't changed it. But whatever it is, that's going to equate to 10 seconds. Now, so that is the case for the getting bigger power up, but for the down one, then we can say if image index is not 0, then else we know it must be 1. So in that case, then we want to change the speed of obj ball. So we can just type in speed here, and then again, of course, make sure that we're setting obj ball, and we're setting its speed back to the start. So I believe we started the ball going off at 3, but because just like before when I encouraged you to set up a variable if you find yourself referencing a number multiple times, let's do that. So let's set up a speed variable for the ball, and we'll set that to 3. And then when it actually goes off at the very start, instead of having it right here reference 3, we'll set it to speed. And back in powers, we can set it back to the start. So now that power up is completely set up, but it's actually not existing in the game yet. So we have to remember to spawn this object when the brick gets destroyed. So we can do that from within the brick object because we do have destroy event. So when the brick gets destroyed, then I want there to be a kind of random chance that it will create a power-up. So we're going to be using another random function. And let's get a random number this time. And I'm going to create a 1 in 3 chance. So what I'm going to say is it can either be 0, 1, or 2. And we'll save that as chance. That can just be in a temporary variable. And then now if we're checking if chance is equal to 0, so that's a 1 in 3 chance because it's either going to be 0, 1, or 2. And if you increase this, it's going to decrease the chance that this variable is equal to 0. Right, so if you want to make it a bit rarer, then just increase that number. So if it's equal to 0, then we want to create a power-up. obj powers. And where do we want to create it? Well, we can just create it at where the brick currently is. So we'll actually just tick relative right here. We'll create it in the instances layer and we can leave this because we don't want to save the ID of this. Now, finally, one more thing. If you've been testing throughout this, you might have noticed that the bricks, despite having a pretty big random chance here to be any of these colors, no matter how many times you test your game, it's actually being created in the exact same color scheme. And that's because GameMaker is actually using a randomly generated seed that it will then use for all of the random functions. And that seed will be kept the same for this project unless we tell it to create a new one. So if you want to do that, then we can run something called randomize, this one right here. And that will make a new seed every time. All right, let's give that a test. There we go. So you should be getting different layouts for your bricks. And let's test the power-ups. There we go. So there we go. We're getting bigger. So everything should be a little bit less predictable now. So that's most of the game done. And now what we're just going to do is add some sound effects to polish it off. So there are some sounds that are going to come with the tutorial, or you can use your own. So for this, I'm just going to open up my folder containing all the sounds. I'm just going to highlight all of them and drag them into sounds. There we go. So I've got a sound for bouncing, exploding, power up, and a kind of click sound that we can use for taking off. So let's put these all to use. So for example, when the brick gets destroyed, we can play that exploding sound. So let's play an audio and explode. And now it asks us if we want to loop that sound, which means it will play it over and over again. So we definitely don't want to do that because otherwise we'll just keep hearing that explode sound. And we don't need to save the ID either. So we're going to leave all of that. When the ball takes off, I might play the click sound. So right in here, the first time that we take off, we will play click. Again, we don't want to loop that or anything, so we can leave that as it is. When we bounce onto the ball, let's play that bounce sound. And the same for intersecting with the boundary. And how about also when we restart that game? So when we had a game over, so when the player presses that button to restart the game, let's also play... Maybe we'll do the power-up sound. And of course then we have to make the power-up when we collide with the bat. And we'll put that outside all of our checks because we want that sound to play regardless of what power-up it is. Alright, so now we've hooked up all of our sounds. Let's check if everything is working. There we go, so we should be getting a lot of sound effects. Alright, so everything seems to be working. That means we've actually reached the end of our tutorial. And now it's just about adding more content to the game. So for example, you might want to add more levels in your game with different brick arrangements. You might want to have your brick colors actually mean something. So for example, you could make it so that all the red bricks are destroyed in 1 hit, but the blue bricks could take 2 hits to destroy. You might want to add more sound effects, have a music track playing, add more power-ups, add a background to the different levels, and also add some different screens. So you could add a menu, a game over screen, all of that. But essentially, that's it. So congratulations on finishing your breakthrough prototype. I wish you the best of luck in your game development journey, and perhaps I'll see you in another tutorial. Bye for now.